Alrighty, I'm going to talk a little bit about contest station engineering, and from the point of view of, clearly the station consists of a lot of things, and I'm going to talk about essentially the indoor part of it. Most of it with the, I'm not going to say too much about antennas other than some of the obvious things, because that's an entirely huge topic all by itself. This is more about how to screw the radio and all of its little supporting black boxes together and make everything play and play well and keep on playing. And I'm also not going to delve into things like SO2R or anything of that sort. There's just pretty much a basic how to reliably build a good performance station. So let's see here. So first off, what's it for? Well, what you want to do is you want to make QSOs, and you want to design the station to make as many of them as you possibly can. And just be aware, as like any competitive endeavor, auto racing or anything else, contesting is a competitive sport. And if you want to get the best results, you're only going to do it by rigid attention to detail. And detail is everything. And lack of detail can make or break the station. So this is there's a lot of little detail type stuff that I've discovered over the years, some of them the hard way. So let's see how it goes here. Okay, so what we need to make QSOs, number one, which has really nothing to do with the hardware, is the operator skill. That's something you can't build, you can't buy, you can't put together out of box. This is just something you got to learn to do. That being said, of course, if you got a decent station, it's a lot easier to build the skills. If you're not fighting the equipment the whole time, it's easier to learn what you're doing and just get away with the operating. And of course, the big thing, the big kahuna in the whole list is you got to be loud. You got to have a good transmitted signal. People, you got to call people and they got to come right back to you, and you got to call CQ and they got to come right back to you, and keep on doing it. That means you've got to have a good transmit signal. That being said, you got to be able to hear the people who are calling you. And in contests, you're going to be an adverse environment. There's going to be all kinds of all of the bad Q things, the QRMs and the QRNs and the QSBs and all of that stuff fighting you. So you need a station that can punch through a lot of those adverse things and drag those calls out of the noise and be able to do it efficiently. Another really big thing in contesting is operator efficiency. Now, if it's a 1 hour CWT or maybe even a sprint, it's okay if maybe, if there's a little bit of stuff, if you got to reach across on the other side to tune the radio, or you've got to look up to see the login screen and all that, you might get away with that for an hour or so. But if you're going to plunk your butt down for 10 or 24 or God forbid 48 hours, you best have the station where the operator can operate at his maximum efficiency for the duration of the contest. And then the other part of the equation is that this station has to operate reliably. And when something breaks, and something will break, and it always happens, you need maintainability. You need the ability to quickly recover from fault conditions and get another radio online or whatever it takes to get things going again. So this is kind of what we're going to be looking to do is mainly the operator efficiency and the station reliability and maintainability, and to some extent, of course, the receive performance, and well, anyway, all the hardware stuff. Okay, on that good transmitter signal, You know, RF is a precious thing that you spend lots of money and effort to make, so you want to make the most of it. And of course, here's the truism about antennas is you just got to do the best you can with what you have. So if you can put up really good antennas, that's hooray for you. If you're stuck in an HOA or something, you do the best you can. But in any event, when you build the antennas, you connect to them, you don't use cheap feed line, and you don't use all kinds of lossy components and cheap ham-fist connectors, ugly things like that, all of which will cost you dBs, small fractions of dBs, but they do add up. When you make your feed lines, you want to make sure that you do them right. You want to terminate the connections properly, and you want to make absolutely sure that they're durable, particularly for the parts of them that live outdoors. Antenna tuners, sometimes you got to use antenna tuners, but just realize that just because the antenna tuner can make the visual meter look really good in the shack, that doesn't necessarily mean that you're putting your RF out. The classic case being the 43-foot vertical with the 200 feet of coax looks real good in the shack, but it's not all that great when it comes to actually radiating the RF. And then of course, have a clean signal. Please don't be wide and ugly. Clicky CW or splattering sidebands, just really, really bad. And it'll run people off. If you're, I know I personally, if I come across a signal that's really dirty, I don't want to work with that guy. I just want to move on. Unfortunately, sometimes you got to move a long way to get rid of them. So it helps to check your signal occasionally. You know, it's another receiver, or particularly one with the pan adapter with a no or a very small antenna, just to make sure that you're not doing something ugly. Okay, let's see. Okay, here, what you're looking for is you basically need to maximize the signal relative to the noise that the signal competes with. One of the key concepts there is you need to match your receiver dynamic range to your mode. If you're doing CW, you pretty much need as much dynamic range out of the receiver as you could possibly get, because you're looking for little skinny narrow signals, which means that they may not have to be too far out of the noise to hear them, provided you can reject close in QRM. Sideband, that's kind of another story, because nowadays, you know, the receivers, even the cheapo receivers, are really, really, really good compared to what they were 20 years ago, but unfortunately not so much the transmitters. So your sideband, you're pretty much going to be limited to the quality of the transmitted signal that the other guys are putting out. So you don't really need 100 dB dynamic range for sideband. 70 would be just fine, because you're going to be putting up with slop that's coming from off frequency anyway. It is nice to be able to hear, of course, and many times, in fact, most times on the low bands, you'll find the transmit antenna is not such a great antenna as a receive antenna. So if you can manage to rig just some kind of a receive antenna, this is an exceptionally good idea. And it doesn't take anything super special, really, just a piece of wire actually can be way better than, for example, a noisy vertical on 80 meters. You really need a way to break the internal connection between the transmit antenna and the receive antenna input. And in the past, this has been a problem. Even the high-end radios did not always provide this. I well remember, I think that was in 1994, dragging a brand spanking new FT1000D home and taking the case off of it and putting it up on the workbench and drilling a couple of holes in the back panel to put a pair of phono connectors in so I could break that internal connection. Because what you want to be able to do is you want to be able to route that out. At the very least, you want to be able to route something along the line of bandpass filters or perhaps noise reduction boxes or something like that, and get them in between the transmit antenna pipe and the receive antenna pipe. But then once you have the receive antenna pipe available, now you've got a place where you can put all manner of different receive antennas. So you can have a myriad of receive antennas going with a single transmit antenna, and gives you a whole lot more flexibility. Okay, another thing that sometimes escapes notice when you listen to a radio in a store or something is if the receive audio is bad. You know, after a while, if you're sitting down for many hours, a noisy or gritty or hissy receive audio will really make you tired. So it's a good idea to try to maximize the receive quality. And in some cases, with the newer and fancier radios that have line level outputs, some of the best things you can do is completely bypass the internal audio strip and run them out through even the cheap old Radio Shack stereo amplifiers are way better than the little one lung IC amps that the people to this day still build into the radios. I understand that the Elecraft people are supposed to be doing really good audio into K4, so it'll be really interesting to see how that works out. And the other thing associated with not having bad audio is the AGC action of the receiver, particularly for CW. What you really want is you want an AGC that gives you some dynamic range. In other words, you want, to some extent, you want the weak signals to be weak, and you want the strong signals to be a little louder, just so you can tell the difference between them. Extremely high AGC loop gains, like, for example, the old R4Cs had, where everything is the same receive level, is a real bummer if you're trying to manage a pileup, because, you know, everybody's at the same strength. Nowadays, of course, in the pileups, everybody's on the same frequency if they're riding spots, so that really makes it tough. So if you can, again, that's where I'll put in a pitch for, I find that the K3 is real good for that, because you can actually tailor the AGC action. I find that extremely useful. And the other thing that's going to get you is local RFI, trash from all kinds of noise sources and self-inflicted wounds from the transmitter. So that's another thing you got to worry about, and you got to minimize if you possibly can. Okay, on the receive side, is modern receivers in particular are really good. Most of them nowadays, the DSP filters, you no longer have to worry about things like filter shape factors and all that. I mean, you're pretty much going to be either in the filter or out of the filter. However, for the cases where you do have signals that are in the filter that aren't necessarily what you want to hear, the ability to use a passband shift and move away from them slightly, or you know, what I can do sometimes is try to actually move the whole radio and drop them into 0 beat. But anyway, you want to get rid of the unwanted signals. And on phone, the high and low cut thing is pretty good because you can tailor the audio to get rid of particularly the monkey chatter you get on sideband. CW reverse is another neat tool. You can sometimes make QRM just go away if you jump to the other sideband. I don't use that a lot myself, but the folks who do it, that they get used to it. Noise blankers, well, if you got noise that you got to try to get rid of, you can try one, but you got to be really, really, really careful with noise blankers. Basically, they're only good for impulse type noise, which I don't guess there's any automotive noise anymore, any spark plug noise. Maybe if you got a guy next door with a hot rod or something, but that's pretty much gone. Sometimes, of course, the offenders can be arcs and any kind of a spark type noise associated with power lines. In that case, the noise blankers can take them out. But the problem is noise blankers are basically intermodulation creators. By definition, signals that you don't want to listen to are affecting the signal that you are listening to. So you got to be really careful, because if you turn on a noise blanker in something like a 160 meter CW contest, it's going to do way more harm than good, because there's just too many strong signals that are going to give you troubles. DSP noise reduction, well, that's a nice thing that the newer radios have. It may or may not do something for you. Usually the algorithms and those things are really good at reducing white noise when you're trying to hear really weak signals. But when you're in a contest battle, white noise is kind of hard to come by. It's all kinds of other noise, but not much in the way of white noise. But play with it and see if you like it. Audio filtering, kind of the same thing. Some of the newer radios now have audio tune filters for CW, which are pretty nice actually. They're very narrow band filters, but they have wide skirts, so they don't ring and make ugly artifacts so much. So in some cases, particularly you're trying to pull a really weak signal out of noise and splatter and stuff, then audio filters can be useful. Okay, this is a big one, the local RFI. There's just all kinds of stuff, as everybody knows, particularly as more and more people get pan adapters now, and you can look up and you can see these nasty little things that start popping up and come drifting through your pass band, and every 30 kilohertz up and down the band and all that kind of stuff, most of which is the artifact of switching power supplies. And of course, there's virtually nothing these days that does not have a switching power supply in it. So there's just going to be lots of that stuff to contend with. Ethernet birdies, same kind of thing. You know, the Ethernet cables all radiate. You'll see these little clusters of signals that spot frequencies. There are filters that can get rid of those, but pretty much for the local stuff. Plasma TVs, thank God those things are going away, because about the only real cure for a plasma TV is instant high velocity lead poisoning, as far as I know, or, you know, maybe a judicious application of 240 volts to the 120 volt line cord. But fortunately, those things are going extinct. They used to be a really horrible problem. But if you're trying to dodge the noise, living with what you got, then a directional receive antenna, such as a small loop or something with a good null in it, or the kind of directional receive antennas you use on the low bands, K9AY loops, something that have a steep null in one particular direction. If you can manage to point the null in that direction, that works pretty well for point sources. Now, you know, if the whole band is full of trash, all you can do is get one big one. Similar thing with the external noise cancelers, the ANC4s and the NCC1s, the NCC2s. You know, if you got one dominant source of noise that you can get on the noise antenna and put in there and subtract it out, then that's good. But usually it's kind of a gotcha. There's just going to be all kinds of stuff to fight. So your noise floor is going to be higher than you would really like. You can try to move to the country. That works pretty well, but not many people have that option available. And if you're in an urban or suburban, maybe sometimes rural, depending on where you are, environment, sometimes you might have a bodacious broadcast station that's giving you trouble with particularly say harmonics on 160 meters. If it's a single station, you can usually build a trap and tune those guys out really well. Or there are available a number of commercially available, mostly low pass filters, or in some cases band reject broadcast filters that they'll do a good job of removing that. And another aspect of local RFI is stuff generated by your transmitter, specifically RF from the transmitter going where it doesn't need to be. That is usually takes the form of common mode RF on your feed lines and on your control cables and everything else. And the fact of the matter is, unless you have lots and lots of real estate, you can put all of the antennas a long way away. Every conductor in your house and certainly in your station is in the near field of the antenna, and hence is really a part of the antenna, which means that it is going to intercept and in some cases re-radiate RF. So what you need to do is you need to discourage that RF from coming down as many of these conductors as you possibly can. Common mode chokes right at the feed points of the antennas is a really good way of keeping that stuff from getting on the coax, because the common mode stuff comes right down the outside of the shield. The shield does nothing for it. The other thing that's good is given it's inevitable some of that common mode RF is going to get into your station. If you make sure that all of the chassis and feed line shields and other ground type stuff associated with your station are properly bonded together with reasonably heavy wire, then you've got a fighting chance, because what that does is that forces the common mode RF to go around things rather than going down into the circuitry of your radio and into your USB cables and all that sort of thing. So it is important to try to squelch common mode noise as much as possible. And another aspect of that is use quality feed lines. Don't get the cheapest RG58 you can find, which is going to have like 75, 80% shield coverage. You really need something that will not let that stuff on the outside get into the inside of your antenna, which means preferably a double shielded type of coax. The LMR families, LMR 400 and all of its various clones that has a double shielding, an outer copper shield and then an inner, usually aluminum clad shield, really helps. If you're looking to get coax, see what the specified isolation of it is. And if it's not specified, or if it's like 45 dB or something, that's not what you want. You want like 90 dB if you can possibly get it. And any of the quality coaxes can do that for you. And be careful about what kinds of antennas you use, because some of them, particularly off-center fed dipoles, are notorious for creating common mode problems, because by definition, those things are unbalanced. So that means that the current is not going to be on the inside the same as it was on the outside. And it gets to eventually you're going to have an unbalance that's going to radiate or be conducted into your station. If you can do it, and again, you know, if you're on a normal lot, there's probably not much you can do about that, is try to get the antennas as far apart as possible. But again, that's more how well you can build your antenna farm. Avoid cheap coax switches that have real poor isolation. You know, you got 90 dB shielded coax, and you screw it into a cheap CB coax switch. It's got 35 dB of isolation. You might as well have done nothing at all. So make sure that any of your coax switches have the best isolation you could possibly get, and make sure that you maintain the shield integrity into them and out of them all the way. And another thing is poorly shielded receiver cables. Same kind of thing. Those are subject to interception of the common mode noise, which can be propagated directly into your receiver input. Once it gets there, there it is. You can't do much about it. Okay, moving on to a slightly, well, completely different subject, but a very important one, is the station ergonomics. Simply put, if you're not comfortable at the operating position, you're going to get tired quick, and your efficiency is going to go downhill. So the more efficient you can be, the less tired you can be, the better your rates are going to be for prolonged times. There's a few key points to that. First one, since nowadays, you know, it's basically, we're all computer operators. The radio is essentially just a highfalutin peripheral to the computer these days. So you're going to spend virtually all of your time while you're contesting looking at that display. So you want to make sure that the display is where you want it to be, where you need it to be, so it doesn't give you troubles. The other thing is the controls that you use with the radio, they should be laid out efficiently so that you don't have to do crazy things like reach way across to change an antenna, or reach way up to change an antenna, or something like that. You want to try to group any of the frequently used controls where they are fall easily to hand. Automation is a really good thing. You want to maximize your automation. You possibly can. The more you can do or have the machine do for you, the less you have to fool with it. And then, of course, just in general, good operator ergonomics, a comfortable chair, that sort of thing. So let's look at a couple of these things. On the display management end of it, it's very important that the stuff that you need to operate is in your immediate field of view. That is, that the primary computer display with your logger screen and all of the really important stuff is centered at eye level. So you're not having to look up and down. And many of us old geezers know, you know, you get into the thing with the bifocal nod where you're doing this all the time to read the display. Not such a good thing. And if that's something you find doing, it's probably worth the money to go ahead and get yourself a set of computer glasses that are focused at the monitor, single vision glasses. That makes a big difference. Of course, you want to maximize the screen real estate if you possibly can, which means big monitors are better than little monitors. Now, and put ancillary displays, stuff that you're not necessarily going to be looking at all the time. Maybe like in my case, I've got the wireless stuff, the wireless controls. I make sure on a separate display that aren't directly in the field of view, but I don't have to glance too far to see them. Same thing with my pan adapter display. Okay, and on the control location, it's a good idea to place the radio so that the main tuning knob, which presumably you're going to be using all the time, falls easily to the dominant hand. Now that may not necessarily be the hand that you write with. I know there's some of us old traffic operators that learned many years ago to, since we were right-handed, we learned to hold a pencil in our hand and operate the key or pedal with the right hand and tune the radio with the left hand. So I always have my my tuning knob over to the left, but that depends on, you know, how you work. But the important thing is don't put it right behind your keyboard, because you don't want to constantly be reaching over your keyboard to tune the radio or to adjust any of the other controls that are important. And a good thing to do is group related functional controls together. In other words, have all of your antenna selection stuff in basically one place, or as close to one place as you can get it. Or in the case of an SO2R station, if you can manage it, is have the main station, if it's your left one, is have those controls on the left, and the other station's controls on the right. And again, the controls that you use more, make sure they're closer to the operator so you don't have to reach them. And then lesser used things, you know, say, in many cases, rotator controls, unless you're in the habit of turning the rotator all the time and you don't have a computer control of it, you don't really want that thing right smack dab in your field of view. It's just taking up a useful space that some more important information could appear on. So now I'm going to show you, here's the way I've organized my station. I'm not claiming it's the best, but I found that this is the most efficient layout for me. Fortunately, when I built the new station, I had the ability to put a nice big bench and to organize it from scratch. So in this case, I have an SO2R station. So the primary radio lives over here on the left, and the secondary radio lives over here on the right. And I keep the keyboard centered with the main display. So there's my main display, which contains my login screen and all the stuff I'm always looking at all the time. In my case, I don't have to reach for the radios too much because I've got a pair of the K-Pod remote knobs, which are really useful because there's a total of 16 different pre-programmed functions you can program to have these knobs do. So they do things like wide, narrow filters and turn and split on and off and all that kind of stuff. So I rarely have to touch either radio. Sometimes to mess with the volume control a little bit, but that's pretty much it. Let's see, in the SO2R control box, I'm not frequently, but sometimes I'm busy punching the, oh, make that thing go away. Oh, wait a minute. Yeah, I don't know. I guess you guys can see that stupid window up at the top. I don't know how to make it go away. Sorry about that. And I have.
Can't see anything. It looks just perfect.
Oh, okay. I've got an ugly Zoom dashboard thing intruding on top of mine. Good. I'm glad you can't see it. Okay. Yeah. And in my case, the ancillary stuff. This is the my monitor for, that's, you certainly can't see it here. There's all of my remote control stuff is green hair and wireless. So I don't have to fool with a bunch of switches. It's all done from keyboards, or mostly automatically based on a frequency choice. So, you know, I put all that stuff over here. This is just kind of a situational awareness NAP3 display that'll show me essentially the whole band, or about 100 kilohertz of it. And then this is the win for K3, which I use to, it is necessary to portion out the the USB ports to all of the various things, but it also has some nice things. It lets me monitor the status of my amplifier and tuner on the main station. So anyway, I found that this to be real good. You know, since I've started operating at the new station here, I find I'm much less tired after, you know, several hours in the chair than I used to be at the old station. Okay, on the automation, there you go. You know, complexity give rise to confusion, which in turn will give rise to errors. And having to do complex manual switch changes in order to change bands or antennas or both, especially when you're tired, is a really good way to screw up. And it's also a good way to make sure that if some poor schmuck wants to come in and operate your station, is he's going to have a great deal of trouble figuring it out. You know, if he doesn't know that coax switch over there has to be on position A if you're going to be on 80 and 40 meters, but it has to be on position B if you're going to be on any other band. But that's only for phone, you know, that kind of thing. So try not to generate that much complexity. Obviously, I can't imagine anybody doing contests paper and pencil anymore. I guess there's a few folks that do it, but I bet they're not running high rates. I bet they're not making big scores. So computer control of your radio and be very familiar with your logging software. Get to learn all the ins and outs and the shortcuts of it. That's something that's really important. Automate your antenna selection whenever possible. So all you got to do if you type, you know, you're on 7038 and you want to go to 20 meters, you type 140130, hit return, and the antenna that is your default for 20 meters is automatically selected, along with any other things such as the bandpass filters, et cetera, et cetera. No tune amplifiers are really nice, and these days are starting to be actually practical. I know in the early days of solid state amps, a lot of them turned into grenades, but I think it's getting a little better nowadays. I've had good luck with my KPAs. I guess Jeff hasn't had such good luck with his, but I think, as I recall, that kind of blew up on 6 meters, didn't it? I don't know, but anyway, it's really handy having an amplifier that you don't have to tune. But if you do have to tune on, make sure that all of the settings that you need for each band are clearly marked. In the old days, I used to have color-coded little stripe tape markers on all of the amplifier controls, as well as the antenna tuner controls. And again, if you really have to use an antenna tuner, consider one of the more modern ones now that will remember settings by frequency and will pretty much take a lot of the load off of you rather than having to fool with resetting an antenna tuner when you change bands or frequencies for that matter. And same thing, computer control of the antenna rotator is good. And every station is different, and every station has some little things that you want to switch and all that. So I'm a big fan of special purpose switching boxes that are made with relays. I like relays a lot. Relays are reliable, relays are cheap, and they are totally RFI immune, unlike USB cables and Ethernet dooguses and all that kind of stuff. So I'm really a relay fan. And of course, I manage mine wirelessly, so that works well. And I would strongly consider it if you're redoing a station or upgrading or whatever that you consider going into a wireless control. It's amazing the number of connectors and cables and all that stuff that go away when you go into the wireless regime. Okay, the operator ergonomics. Said before, you want that home row of your keyboard right in front of the computer display. And you want where you can see you don't want to have to bob your head a whole lot. Now, obviously, if you got to look down at the keyboard a little bit, it's just the way it is. One of the important things that I've learned to do, it's taken a lot of practice, but is learning to touch type well. I think that's been an extremely valuable thing, particularly for running high rates. So if you can force yourself to do that, it's a lot more efficient than the one finger peck type stuff. But I know a lot of people do that. A good seat, a good chair is very, very, very important. As a matter of fact, I've got a brand shiny new one I just picked up this week that I think I'm really going to like a lot. This one is built as a gamer chair, and it is really, really nice. It's got lumbar support and all kinds of stuff. First, it was kind of off-putting because it feels like it's rock hard, but you sit in the thing for a while and it just feels good. Subdued lighting if you're going to be operating at night. Another thing is, at least this is kind of one of my pet peeves. Maybe other people aren't so sensitive to it, but I don't want a bunch of desktop clutter around the keyboard and in front of the radios and all that. So I do everything that I possibly can to interconnect all the controls, including microphones, keys, all that stuff on the back panel of the radio. Or at the very least, run the cables from behind and underneath the radio or around it. So you don't have too much stuff in your way. Again, we talked about receiver audio quality again before, and really, a lot of radios have a lot of audio hiss, and a good way to manage that or to mitigate that is make sure that your headphones are not high quality stereo wide range phones. You really want a set of headphones that are tailored to communications band. I mean, they ought to start rolling off about 3 kilohertz. You don't need 10 kilohertz response for the things. All that does is emphasize the high frequency noise and makes you tired. I found that the radio sport headphones are about the best. I know people like the Hiles too, but don't cheap out on the headphones to save a few bucks, because you'll be surprised how much more relaxed you feel when you're not fighting audio noise. And if you have multiple headphones, and of course for long contests, it's always a good idea to change them out occasionally. Take a little break, change headphones, and that can help a good bit too. All right, so we said we need high equipment reliability and maintainability. So what does that really mean? Well, it boils down to carefully designing the station layout and signal paths and all that sort of thing. Only use high quality cables to interconnect all the boxes. And a very important one that many people fail to realize it is important until they get into trouble is you need to maintain good documentation of what you have. So you want to be careful about the station design. You want to plan the equipment layout, which of course gets into the ergonomic factors as well. But where the RF and control cables go, I know everybody nowadays has run into the problem of the 1 pound black box with the 8 pounds of cables on the back of it that you can't make sit still on top. And so try to avoid having ugly things like that if you possibly can, but sometimes you just got to deal with it. You want to design the stations, design the station for maximum flexibility. That is, you be able to make changes and to use all kinds of different antennas, different receive antennas, for example. The more different things you can do with them, the better it is. And also, you will get more stuff. It's just like everything else, stations grow. A few more boxes, few more doodads. So if you plan going in that you're going to have some complexity growth, just be aware of that. That primarily means if you possibly can, leave yourself as much extra room as possible in the initial station layout. Also, plan to have backup hardware if at all possible. You know, you may not have a full up backup contest grade radio, but maybe you do. But in the case of something fails, know where the replacement is and how to get to it and how to connect it up, preferably as quickly as possible. And if God forbid it's a transceiver failure, try to have maybe, if there are different types of transceivers you got to swap out, try to have maybe some adapter cables or something ready to go so it can more or less go into the existing layout without a great deal of trouble. Okay, we're back to using good quality cables. I found over the years that the bane of RFI problems and just reliability problems and all that is cheap interconnects. Old Radio Shack molded RCA cables, stuff like that are just horrible. You know, they don't grip into the jacks. They're not shielded well. What I've standardized on doing is I build pretty much all of my own audio and interconnect, control interconnect stuff. And I use stranded Cat5 cable. Cat5 cable is nice because it's got 4 sets of twisted pairs. And the twisted pair is very nice because that inherently has a whole lot of RF rejection. So like, for example, stereo audio stuff, I'll double up 2 of the twisted pairs, one for the left channel, one for the right channel. And the stuff is cheap. I bought, I think, 100-meter roll of it off of eBay many years ago for like $30. You want to make sure you use the stranded stuff though. You don't want the solid because, you know, putting it in the bind or flexing it, eventually it's going to break. So make sure you use the stranded stuff. And use good quality connectors from reliable sources. Hamfest connectors are generally cheap for a real reason. And don't stand on getting good quality stuff. You know, I use REAN, R-E-A-N audio connectors pretty much for the 3.5 millimeter, 1/4 inch audio plugs, the RCA connectors, and then Amphenols. And I don't have any deep DIN plugs anymore. When I had DIN plugs, the Amphenols are about the only ones that the cable or the connector body itself wouldn't melt if you got a soldering iron even close to it trying to connect a wire to it. RF connectors, pretty much Amphenol is the way to go. Although DX Engineering also has good quality connectors. I've seen a lot of cheap imported PL259s, SO239s that the threads aren't even right. So don't try to save money there. Don't do that. As we've discussed before, you want to use quality, well-shielded coax, not the cheap stuff. And you want to terminate it properly. There's all kinds of schools of thought of how to build UHF connectors, but it's been my experience that the way to do it is like the Amphenol thing. tells you to do it. Complete with the soldering the shield through the little holes. What that means is you got to have the right tools. And in the case of PL259, that means if you're going to build a standard PL259, is you got to have a big mother soldering iron, not a gun, not 100-watt iron. I'm talking about the 200-watt, 150-watt, at least Black Beauties, those great big 4-pound devils. Those will do it because they've got enough thermal mass to heat up the connector. Lately, I have converted over to the crimp connectors. Again, the DX Engineering people have a really nice family of, it's hybrid actually. The shield is crimped and the center conductor is a nice beefy solder pin. So it's kind of the best of both worlds. And if you get good quality crimp connectors and you use good quality crimp tools, not the $30 Hamfest ones again, but something like the DX Engineering tools, crimp works well. I had to build several dozen RG8X or LMR240 UF cables for my bandpass filter switch and a whole bunch of other interconnects, and I did it exclusively with the DX Engineering crimp stuff. I've been real happy with that. I've had zero reliability problems. Now, maintain good documentation. This is where I know a whole lot of people fall down. And at one time I was guilty of it myself. As a matter of fact, I think KU80 may remember a couple of times at the old W8FN station in New Carlisle, Ohio, where he or somebody else would be doing a multi and he or somebody else would root me out of the bed in the middle of the night and say, something's not right, it ain't working. And I would go down and I'd roll underneath the bench, and sure enough, I would see a red Radio Shack RCA cable end dangling. I had no damn idea where it came from or where it went back to. Oh God. So I learned the hard way over the years.
Probably your cat.
Well, yeah, no, I was probably just an errant foot, but yeah, the kitties can do things like that too. I've been pretty lucky. I haven't had to beat too many cables or anything, but I learned the hard way that you want to label every cable without exception at each end. And preferably you want that label to match what the label is of the spigot that it's plugging into. If it says, on your transceiver, it says PTT out, then that's what you want that label to say. If it says TX, that's what you want that label to say. Same thing on the other end. The other thing is you need to draw up or at least list out all the interconnections, which can be a daunting task if you got a complex station. And then if you've got some homebrew hardware, relay boxes and all that, you really need to draw schematics of them, because sooner or later something will not be right and you got to know how the thing is built so you can fix it. I've gravitated toward using these tie wraps with flags on them. These work real well. Actually, this is an old picture, as you can see, with the DIN connector. And I've since gone over, I found that you can get them now with the tie wrap end below the flag, and that's where you really want it, because this variety here, what happens is when you tighten it down on the cable, it kind of rolls the flag, whereas when it's down here, the flag sticks out nicely. And I use a brother label maker with the stick-on labels to make the labels and just stick them on. Do not be tempted to write on these with Sharpies. That looks real good for the first month or so, but you get a little UV or just age on them. By the time you need to fool with them, you won't be able to tell what it said.
Hey, Randy, a quick question. Where do you get those tie wraps with the thing to put the labels on? I could never.
I bought them from Amazon.
Okay, because I could never find those.
Okay, let me make a note here. Who is that hollering? Is that Jeff?
Yeah.
Yeah, okay, I'll put that on the reflector, real quick, make a note. Yeah, they're pretty cheap. I think they're like a bag of 100 of them's like $4 or something. It's really, really reasonable. So anyway, every cable I have is labeled. And again, I strive to make the label reflect exactly what it connects to says. Now, when you got a whole bunch of interconnections, this happens to be one page of my station interconnect. You see, my station's pretty complicated. It's real good to document how these things are connected. In this case, probably overkill, but being an engineer, pseudo OCD, all that sort of stuff, I make sure that I specify you'd have to blow that up to C, but I specify the type of cable. In this case, that'll say UHF, that'll say B and C under there. That's a receive antenna in. And then that label is what's on the flag label. Now, sometimes I can't get all of the flag labels on the schematics, but I get most of them. So that way I know exactly what goes where. And this is also real handy if I need to reconfigure the station, because I can sit down and write myself out a thing, pull this cable and, change it to here and do that sort of thing. So you really want to document the wiring. And the other thing for stuff like this multi-conductor control cables, this happens to be my old, the old Texas in the attic before I went to Green Heron Wireless. This is one of the dozens and dozens of cables that I had to be able to control the antenna switch. And I've got some AB switches that basically steer the unused antenna on the other side of the double 10 switch, so I can use it to receive antenna on the active radio. But anyway, all that stuff. So it's a real good idea to make a drawing like this, or alternatively, or in addition, as I do, is actually write it out in a tabular form. And the schematics, if there's something that you built, it's good to know what it is, and so you can go retrieve that and fix it if necessary. Okay, and the other thing that you want to do is you want to use the station. You want to run it continuous shakedown and improvement. And a good thing to do is work DX, although there's not a lot of that these days, God knows, but maybe one of these days there'll be DX to work again. Work some of the minor contests, the QSO parties. If you're a CW guy, boy, the CWTs are really great. They'll keep you on your toes operationally and then also make sure that your station's working right. And if you find problems, fix them right away. Just don't wait till like Friday before the big contest. I remember many years ago, I guess that was in the early 80s, one of the Mad River Radio Club guys, now Silent Key, I believe. I recall going to his station and seeing that he had a desk mic, and he had a great big piece of duct tape taping the cord to the table. I said, why'd you do that? And he says, oh, it's got a broken shield and on that cable. I don't want to fix it, so I just put that tape on it. Don't be that guy. It's going to give you trouble at the worst possible time. Same thing if you decide you got a station enhancement, a really new black box that's going to do wonderful things. For God's sake, check it before you screw it into the station and jump into a big contest, because there'll be something you did not expect, and it'll get you every time. Okay, so this is just kind of a recap of where we've been. Want to minimize your RF losses and transmit a good signal, have a good transmitted signal. Get the best receiver performance and flexibility for that matter that you can manage to get with the hardware you have. Get rid of as many local RFI sources as possible, including all of the wall warts that you can stalk down and kill, and use maybe linear supplies for in your station. I neglected to mention that in my station proper, I have 0 switching power supplies anymore. Of course, like everybody else, I've got routers and there's dozens of wall warts. And I discovered that our shiny new washing machine that came with the house generates all kinds of really interesting crap on 20 and 15 and 17 meters when it's running. Just ugly stuff. So fortunately, the antenna is far enough away from the house that it's not a big problem. Make your station as ergonomically efficient with as much automation as possible to keep the operator fatigue factor down, and make sure your hardware is as reliable and maintainable as you can possibly get it. So that pretty much sums up what I had to say. So I guess anybody's got any questions or comments, I'll be glad to entertain them right now.
Sure, Randy, this is Jeff, W4DD. What size was your main station monitor? I couldn't tell from the picture.
It's 32 inch.
Okay. Is it more than a 1080p or just the standard 1080p?
I'm not real sure. Didn't cost very much money. It was like $270 or so. So I don't know. I really don't know what it supports. It may be all of the 4K and all that stuff. I just found one that I could mount to the wall and look pretty good, and ordered it from Amazon. It's worked like a champ.
Okay, thanks.
Hey, Randy, where do you buy your connectors from, and your coaxial cable? Because I know Amphenol are pretty expensive. I mean, are the ones that DX Engineering or Max Gain or the Wireman, are they considered cheap connectors?
The only sources that I would recommend for UHF connectors would be honest to God Amphenol's or some of the DX Engineering stuff. Now I think that maybe like somebody like the RF Connection in Maryland and somebody like that has good ones, but there's so much crap out there that you really need to stick with brand name stuff. And good quality UHF connectors are just expensive. And that's just one of those things you got to get over. Just putting cheap connectors on your coax is the worst possible economy that you can possibly get. Just what's that they say, the sweetness of the cheap price wears off long before the bitterness of the poor quality, something like that. So I strongly recommend genuine Amphenols. I get most of my Amphenol stuff from Mouser. I don't know whether DigiKey handles Amphenol or not, but I know Mouser does. Mouser is a really good source. Those people have a really good ordering system and all kinds of things. So they're my go-to people for all of the audio connectors and all that sort of thing.
And they have great Cat 5e and Cat 6 cables too. I've ordered a bunch from them. Yeah,
they're an industrial supply. They cater to industrial people, and that's hence it's quality stuff. They don't deal in shoddy hamfest type stuff. And unfortunately, it does cost money. But I mean, you got a big investment in all these electronic doodads, and it's just false economy to cut corners on the what's the idea of this stuff? Well, it's to make that RF. So you don't want to cheap out on the connectors that are integral to carrying that RF where it needs to go. It's just as simple as that.
Yeah, Mike Roden. Go ahead, Jeff.
Oh, I was going to ask Randy, so if you don't get Amphenol, are the silver plated ones better than the Teflon?
Well, the silver plated ones are certainly what you need if you're going to solder them properly. Yeah, boy, some of these don't ever get the nickel plated ones, the shiny ones. Some of those things won't take solder at all. I remember years ago having some of those things, and I had to literally file them down to the brass to make solder stick to them. So yeah, you definitely want silver plated. The 831SP is the Amphenol number. That is the silver plated one. That's the one you want. And really, you know, the Teflon dielectric buys you essentially nothing at HF. I mean, it's not going to do any RF good. Now, it does have the advantage of it's hard to burn with a soldering iron, but you shouldn't be having a soldering iron there. Plus, the genuine Amphenol 831SPs have that brown phenolic or whatever it is, and that stuff is pretty well resistant to burning too. If you're using enough heat to melt insulation or something, when you're building UHF connectors, your soldering iron isn't big enough. That's a sure sign that iron's not big enough. If it doesn't have enough thermal mass to get in there and get after it and heat that connector up in a big hurry to where you heat it all the way around, and then all you got to do is go and just stuff a little piece of solder in each one of those 4 or 3 or 4 holes, however many it is around there. And if that thing's good and hot, it'll suck that solder down, and you could be on and off that connector in 45 seconds or so and have it completely soldered to spec. But you're not going to do that with the gun.
Mike, W5JR here. I'm using RG400 for all my shack cables. I've ran across several hanks of it at various hamfests.
Oh, lucky you. That's
yeah,
really good stuff.
It is. And I also use the CREP connectors using the King's Industries CREP connectors.
Yeah, King's is a reliable one, of course. Yeah, that's a cell site type stuff.
And RF Parts has the exact King's connectors for whatever cable you're going to use, LMR or RG 400, RG8X, or if you have RG223, which is kind of like it's a double shielded cable, also like RG400. But you want to avoid RG142 because, like non-stranded cat cable, its center conductor is solid.
That's also copper coated steel, isn't it?
It's copper coated beryllium.
Oh, geez, that's even worse. Yeah, you don't want that.
That's an environmental hazard.
How do you strip the 400? I've been wondering, just the regular stuff that'll work for RG58 also work on it?
Yes, you have to make sure you have your knife blades cut or set correctly for the double shielded RG400. But once you do that, then it's just a simple strip and away you go.
Now,
Randy, can you kill the share so we can see everybody?
Oh yeah, sure. Let's do that. Let's see. Stop share. Yeah, no sense looking more better. Yeah. There we go. Might as well stop my slideshow to you in the background here.
You should have
go into my video share. One of the other things that I did a long time ago, back in the days when we did all hand logging, being right-handed, I would log right-handed during the contest. I taught myself to send CW with my left hand on the keyer, so that I could write while I was, or send while I was still writing. There were no keyboards in there.
And I know there's a good many guys that do that. I briefly tried that many years ago and said, "Oh, this ain't for me." I handled a lot of traffic, and I just got to where I could hold the pencil and manipulate the keyer panel. So that was how I learned to do it. But yeah, everybody's got their own technique.
I'm probably fortunate that I did that 50 years ago, or I probably couldn't be able to do it today.
Old dogs don't learn new tricks too easily.
Just
Hey,
one of a long list of things you can't do today.
Yes, sir.
Hey, Randy, if you remember, I learned backwards. So my pedals wired for a left-hander and I
Oh,
send
yeah.
right-handed.
That's right. I'd forgotten that. Yeah, I remember that causing some consternation a few times. What the hell? Yeah.
I
That's why
try,
that's why all my paddles have a little miniature toggle switch on them, so I can switch between left and right.
Yeah, I did that. I had a couple of 3 benchers that had little teeny slide switches on the back of them. Nowadays, you turn it around electronically, but in the old days, you couldn't do that.
I tried to switch one time, but I had done it so long it was
Oh.
impossible.
Yeah, once you got that muscle memory, you're screwed. It's just no point fighting Mother Nature at that point.
Jeff, I think KB4 KBS shares that same dilemma, that he learned with the paddle incorrect and can't unlearn it.
Well, the way I think about it is the dashes. It's better to drag your thumb for a dash. That's the way I look at it, instead of having your finger do the dash.
I'll let you know. Of course, I guess the dash dot convention really goes back to the classic old bugs.
Correct. Yeah, and those that used a right-handed bug, left-handed, didn't get a left-handed bug. Those are pretty rare.
Yeah. Yeah.
But I rarely use my paddles in a contest. I'm using the computer most
really?
of the time. Oh
Oh,
yeah.
I'm constantly on mine for fills and stuff. I mean, I just have to. Matter of fact, you work me in a CWT and you and if I send your call at the end of the exchange, what that means is I said it the first time by hand because I'd screwed up somehow typing it to begin with.
I have a question.
Sure.
Am I heard here?
Sure.
Okay. Thank you, Randy, for the presentation. You mentioned more about coax switches and isolation. I know there was a good article in QST in the last year. What are some, to the group or you, recommendations of a trustworthy coax switch brand?
Talking manual or automated?
Manual initially.
Oh, I don't know.
Okay.
I don't know. The manuals tend to be old designs and therefore not as good. I guess if you really press to get good quality manual coax switches, if you look for some of the microwave jobs with the end connectors, the big old honking military types, those are probably quite good. Anything that's rated to operate up to S-band or something is probably going to have to work well. But the old Dow keys or what, I forget what they were anyway, the old manuals. And
we'll have to sweep some of the B&W key.
BMWs.
Yeah, the B&Ws from years ago. I think I've got a couple of them.
I remember
I'll have to
those.
put
Yeah.
those. I'll have to put some on the analyzer and see what kind of return loss and isolation there is.
Yeah. Now, at one time, when they were Daiwas, the little die-cast Japanese 2-position jobs were pretty good. They were rated up to like 600 megahertz or something. I think they were pretty decent. But you don't want to buy the one that looks just like them from MFJ.
Yeah.
A little blue.
Alpha Delta also sells some that are intended to be used up to 500 megahertz. Those have end connectors on them.
Yeah, that's the ones that they put the UHF connectors on are probably no great shape, but maybe the ones that they sell to people that would insist on end connectors and need end connectors, they might have to make them work.
Well, if you want one with relays in it, I have the Array Solutions, the Red Pack, and they actually use real good relays. Because if you ever open an MFJ, there are these little tiny relays, and all the Array Solutions are big, like relays. Like the 6-pack has those in them, and the Red Pack that I have has.
I fought a 6-pack for a long time. It wasn't so much isolation problems, but I just had reliability problems with the Fool things. They were real picky about the supply voltage and everything else. And I finally retired the 6-pack and went to the micro ham box, which it, like most of the modern ones, it uses the 16 amp sealed automotive or just general purpose sealed relays. And those work pretty well. Although I did have to replace some just the other day.
Two comments. The Daiwa switches have been rated really good. They have at about 60 dB isolation. And I use an Array Solutions 8-pack. And one of the things they recommend is start playing around because they are in 2 banks of coaxes. And if you put the bands, similar bands close together, you have isolation problems. So you need to kind of stagger your antennas between the 2 different banks.
And doesn't the 8-pack use the sealed relays? I think it does.
Yeah, it does.
Yeah, those funky old clunky things that are in the 6-pack. I think the Array Solutions must have got a really good deal on those. And I think what they probably are is they're actually some sort of an industrial thing that was originally rated for 24-volt service. I've got my suspicions that that's what they've been doing with them. But anyway, yeah, I prefer the sealed relays very much to the old open frame guys.
Well, you know, John, K4BAI bought one of the Green Heron, the Select 8. That's a really nice wireless. Yes. Are you using one of those, Randy? Because I noticed when you brought your screen up, you had the GH Anywhere up.
Well, no, what I've got is I use the GHE stuff, but the on the remotes, you know, they all have at least all the ones I get, you can get them with bare transistor outputs, which I would never recommend because if you short them, you kill them. They just got little read relays. But what I do is if you go into Amazon or a bunch of other Adafruit people like that, you can buy 16 power relays on a board, all built up with logic level inputs and all that for like $14 to $18. So that's what I use is I buffer everything with those relay boards. So I'm just using those relays, and then they're driving the micro ham is just it just uses it's high side switching. That is, you know, it's positive 12 volts to pull it in. Now some of the stuff, for example, I use an awful lot. I've probably got maybe a dozen of them in my station lineup of the top 10 AB switches for changing configuration. I use a couple of them for bypass and each antenna tuner and that sort of thing. And now those are low side, but that's the beauty of those Chinese relay boards because they're single pole double throw relays. So you can configure each individual one. If you need a normally closed to ground, that's cool. If you need a normally open to ground, that's cool. If you need an active high. So and then it's just a matter of programming the GHE stuff to make it do what you want.
Do you use power pole connectors for your power supplies and stuff?
Some for the transceivers, yeah. But I don't have too many things like that. I think I put a set of power poles on my station 12 volt supply when I discovered that. I didn't know that for a long time until I got my beverages, because I had all this ugly noise. I'd been congratulating myself. I had a switching power supply in there. It was making 12 volts for all accessories. And it never give me a lick of trouble until I put the beverages up and I discovered that sucker was making noise. So I ripped the switcher out of it and just used all of the terminal strips and LEDs because it was real nice. It had like 18 individually fused and LED annotated outputs. So I got rid of that thing and patched in I think it was a 12 amp Astron. And I use power poles to connect that back into the hull, but I don't have too many power poles.
Well, you'd have to power your K3 with that.
Yeah.
Yeah.
Well, the K3, each of the K3s has a dedicated Astron 35 35F linear supply. Like I say, I don't have any, I no longer have any switching power supplies that I use in the station. I got a number of Astrons that do some 12-volt stuff for some of the remote switching and all that. So no noisemakers in the radio station.
I used to hate putting on those connectors, and then a couple years ago, I bought the crimp tool. It's so easy.
Yep, the DX engineering crimp tool does those as well. Works like a champ.
I use or I second your DX engineering crimps for coax. I changed over 2 years ago, and man, that thing is really a nice connector. I appreciate that. I have another question for you. Your automatic rotor control, how sensitive is that? I do mostly search and pounce. And if I work a station that's 5 degrees off, is that going to spin the antenna?
I can't give you a definitive answer because right now I don't have a rotary antenna. I haven't had a rotary antenna since I took the station down in Texas. You might have noticed I had an instance of PST rotator as running on my desktop, but that's what that is. That's a real Rube Goldberg thing. That's the only way that I can pipe data out of DX for Win and put it in the format, the UDP format that the Green Heron stuff needs. So it's kind of a kludge. I did use it with the stepper and one of the ERC controls, but that's a matter of you could set up some of that stuff, I believe. I know in PST Rotator as, which I really like. That's a great program. It does a whole lot of things other than turn rotators. And
I'm pretty sure in the Green Heron rotor that you have the option to adjust how big of a change triggers a recentering, and you can base it on whatever the beam width of your antenna is. I operate a friend of mine's here. Well, one of the guys, most of y'all probably know, W8FN's station. I operate his station quite often remotely from my house with his 2 Green Herons and his 8-circle receiving array. So it's really nice.
Yeah,
much better than my wires.
Yeah, the GHE box, you're right, because I haven't done a complete checkout on mine. I've got one that's going on the new tower when it goes up, but I got that part of the deal. Yeah, it's got the RT21 and a Orion 2800. I haven't got the rotor itself out, but I did go through some of the setup stuff, and I discovered a lot of it I can't check out until I get the rotator connected to it. But I do remember there was that thresholding in there. So the Green Heron, that's first-rate stuff. That's really the way to go.
Yeah, if you want to find out about all that, W2F, I think it's W2FU owns that, or
Yeah, W2FU.
yeah.
Sure.
He did a presentation, I think it was for either Visalia or the Contest University, that tells you everything about the Green Heron.
That was Visalia. That was a really good one.
Yeah.
And I think that's online, I'm sure.
Yeah, it is.
Yeah, Jeff's a good guy. He's really knowledgeable, and he'll help you all he can. So he's a real good guy.
Yeah, actually, when John bought his, we were having problems with it, and he just sent John another box.
Well, early on when I was getting into the thing is I got one of the, I think it was a 16 relay jobs, and it was, some of them were working and some of them weren't. So I got into the thing and got to looking and discovered that it was basically just a bad solder job on the decoder chip on a little kind of a daughter board that's in there. And I told him about that. And he says, "Oh man, I fixed it. It wasn't a big deal once I found it." And he turned around and sent me another one.
Yeah. I mean, he actually remoted into John's computer trying to figure out what was going on, and he couldn't. And he said, "I'll just send you another one. You just keep the old one." So
Yeah.
he's got the extra one with the Wi-Fi antenna on it.
Yeah, the Green Heron stuff is really great. There's only one problem that he said he thought he could fix. Now he says he's not sure he could, is when you have the second radio instance of it up, is you can't assign hotkeys to them. You can only assign hotkeys to the primary, and it's some convoluted thing to do with the way that the Java business that runs it works. So I guess he'd have to completely tear up and rewrite the program or something to make it work. So he says he didn't think he's going to do that, which is a real disappointment because it's really slick. I've got it set up where when I want to change antennas, I just use a control numpad number and I can pull my antennas up without ever having to touch anything with the keyboard.
Another question, not directly related to contesting. I've got a friend lives in HOA. He's not a contester, and he's got all kinds of RFI from all the houses real close to him. You mentioned about noise cancelers and that the 1026 is primarily a single source. Are there any noise cancelers out there that you know of that do multiple?
I think that's inherently impossible due to the physics of the situation. I mean, one of them has to hear the noise more than the other and subtract it out. And it's just inherent. I mean, by definition, it's a phasing box. Even the fancy NTC2 is a sophisticated phasing box, and that's all you're doing. You're doing phasing tricks, and you can only do them on one signal at a time.
Yeah, that's kind of what I figured.
Yeah, it would take some sort of a highfalutin digital processing to do that. And I wouldn't be surprised in the next few years, once the product becomes mature and all that, to see stuff like that start showing up, certainly in the K4.
DSP would probably do it.
Well, they've got enough power in there, and they got this gleam in their eye about things they can do. And unlike the K3, they're in no way limited by computer resources in that box. So I expect to see all kinds of, spectral cancellation and all kinds of stuff in the out years, but not right now.
Yeah. Randy, if you'll allow me, there's probably some other questions. I mentioned to you before about I bought a used MK2R Plus, and when I got it here, I was having connection problems. It was sending push to talk signals and losing connection with the radio initially about every 10 minutes, and then it got down as it heated up to every 2 to 3 minutes. Been in contact with Microham over in Europe, and in fact, they did get a bad batch of opto couplers in the USB line, and they, for several units, this one was from 2012. As that thing gets aged, the LED light inside dims out, and it begins to have connection problems. So considering the lifetime, and I just had one pop up, you're going to probably start hearing of that more and more. Joe here of Microham in the States said he didn't even know about it. So if you hear of people having connection problems, that probably ought to spread around in the contest community.
Yeah, that's a good thing to file away. You might do a post to that effect on the Microham reflectors, so it'd be in the archives.
Yeah, that's true. I swapped out the optocouplers. He said Fairchild works good, and that's what he normally uses. But that bad batch, he couldn't get some, so he bought an off-brand, and that's the problem that he has.
These through-hole parts?
Huh? Yeah, it's a double-sided board, but
that's real good. Although it's a major pain taking on those things apart, but it's better than having it all surface mount.
It wasn't bad at all. But anyway, it's working fine now that I swapped them out. $2 for the parts, and off we go.
Yeah, maybe lay in a supply of those just to have them.
I got them if anybody needs them, but Mouser's got hundreds.
There's nothing worse than those flaky intermittent things like that.
Yeah. Anyway, back to you.